Assalamualaikum warahmatullahi wabarakatuh and hi, my name is Muhammad Faris bin Abdul Hadi, metric number 180068 from Department of Chemical Engineering Technology, Faculty of Engineering Technology FTK, University Tun Hussein on Malaysia. To all my beloved panels, today I will present of my final year project 1 or PSM1 with the title of Performance of Green Oxide CN Nanoparticles on Polluted River Water Treatment using Membrane Photocatalytic Reactor MPR. My supervisor for this project is Technologist Dr. Nurhanis Hayati binti Hairom and my co-SV is Technologist Aida binti Muhammad. For your information, I have started for my lab and get the result for my first and second objective of this study during physical class, and I have used them to participate in 7 international biotechnology competition and exhibition I've set in UTM Skudai. Ladies and gentlemen, let's go to introduction. In Malaysia, there are 672 rivers recorded in 2019 based on Laporan Kualiti Alam Sekitar 2019. From this value, 408 showed clean water quality, 205 were slightly polluted, and 59 were polluted. The number of contaminated rivers has risen marginally from 8% in 2018 to 9% in 2019 as shown in the figure. Department of Environment DOE had listed 6 standard parameters used in measuring the level of this polluted river water, which are pH, color intensity, chemical oxygen demand COD, biochemical oxygen demand BOD, turbidity, and ammoniacal nitrogen. The conventional method used in treating polluted river water such as flocculation, filtration, sedimentation, and chlorination. There are currently no established pollution treatment methods that provide effective color rejection of polluted river water. According to the pioneer reports, as a result, a hybrid system that combines membrane filtration with the photocatalytic method is an innovative alternative approach that has the ability to increase the wastewater treatment efficiency and minimize flood decline, can be applied increasing the performance of polluted river water treatment. Let's go for the problem statement. Polluted river water that mostly from the industrial sources contain a high concentration of organic compounds that have been discharged into the main river. This polluted river water can cause the impact to disease for humans, especially for drinking water, destruction of ecosystem, eutrophication, which is encourage the growth of algae, and effect for the food chain for aquatic animals. There are currently no established pollution treatment method that provide effective color rejection polluted river water according to the pioneer reports. There are numerous publications on green synthesis of zinc oxide nanoparticles and plant extract currently available. Unfortunately, no experiment has been performed using Cymbopogon extract, which is why the study was conducted. In order to address part of analysis problem stated above, this research is focused on the following objective. First, to synthesize zinc oxide Cymbopogon ZnO-CN nanoparticles via precipitation method. Second, to evaluate the performance of zinc oxide CN nanoparticles for polluted river water treatment via membrane photocatalytic reactor MPR. Thirdly, to elucidate the characteristic of membrane falling using atomic force microscopy AFM. For the research scope, firstly, the zinc oxide CN nanoparticles will be synthesized with precipitation method under different CN loading 1%, 4%, and 8%. Secondly, by using FTIR to show the wavelength of the functional group. Thirdly, the best pH of the polluted river water will be selected and treated in MPR under 3 types of membranes, which are microfiltration, nanofiltration, and ultrafiltration. Firstly, then the comparison performance of zinc oxide CN and zinc oxide commercial under the base membrane will be run. Fifthly, the quality of permeate will be determined in terms of pH, color intensity, BOD, COD, turbidity, and ammoniacal nitrogen compliance to national water quality standard for Malaysia. Sixthly, elucidation of topography, surface morphology, and roughness of membranes using atomic force microscopy AFM. As we know, rivers have long been recognized as one of our essential water sources. It has served as a source of water for population and industry, as well as a transportation route for materials and goods. The figure shows the national water quality standard for Malaysia. One of the indications of BOD present asserted by organic contamination is dissolved oxygen. Inefficient treatment of sewage or effluent from agro-based and manufacturing business is one of the cause of high BOD. The ionized form of ammonia is ammonium. The presence of ammonia or ammonic nitrogen pollution in river can be detected by measuring ammonium, which is also improved by pH and temperature variations. Animal farms and residential sewage may be the main sources of ammonic nitrogen, while poor earthworks and land-clearing operation were the main sources of total suspended solid TSS. pH is scale-based measurement of acidity and alkalinity. Turbidity is a measure of the amount of suspended particles in a river. Okay, next, we move to zinc oxide nanoparticle. According to some sources, a photocatalyst should have the following characteristics. Firstly, high activity. Secondly, resistant to poisoning and stability in long-term use at high temperature. Thirdly, mechanical stability and resistant to attrition. Fourthly, non-selectivity in most cases. And fifthly, physical and chemical stability under various conditions. Zinc oxide is a semiconductor with a similar 3.4 eV broad band gap. Zinc oxide, stable woodside crystal structure, has a high excitation binding energy, 60 MeV, allowing it to produce UV light efficiently at ambient temperature. These properties have made zinc oxide a desirable photocatalyst for photogradation-based remediation of polluted river water. What is capping agent? Capping agents are tiny molecules, ionic species, or even macromolecules that can bind specifically to a facet of a crystal to prevent nanoparticles from overgrowing and lowering surface energy. While capping agents are typically used as a physical barrier to prevent reactants from freely accessing catalytic nanoparticles, they can also be used to improve nanoparticle catalytic performance. Ladies and gentlemen, what is Cymbopogon nardus? Cymbopogon nardus, or serai wangi, belongs to Penisidae family or Grimelids and well known as one of the traditional medical plants. Cymbopogon nardus plant is green and purplish red stems, green leaf color to bluish, flat elongated leaves reasonably red. If the leaves are squeezed, it will smell distinctive aroma, same as figure shown. It contains phenolic chemicals such as flavonoids, terpenoids, tannins, gallic acid, sterols, which are believed to be necessary for nanoparticle capping. When the green leaves of this grass are crushed, a strong citrusin is released. The herb Cymbopogon nardus has been utilized in fragrance, cosmetic, and cuisines. Okay, next, we move to membrane photocatalytic reactor MPR. The membrane photocatalytic reactor MPR, as shown in figure, is utilized to remediate contaminated river water in this study. MPR is a hybrid reactor that combines a photocatalytic degradation technology with a membrane filtering system. Photocatalytic degradation was used as a pre-treatment in MPR, and it was able to reduce membrane fouling and flood reduction. The membrane serves as both a simple barrier for the photocatalyst and a selective barrier for the molecules that are being degraded. Most MPR processes, such as microfiltration, nanofiltration, and ultrafiltration, combines photocatalysis with pressure-driven membrane process. MPR have certain advantages over conventional photoreactor as a more advanced alternative to standard approach. The advantages included membrane confinement of photocatalysts in the reaction environment, development of a continuous process with simultaneous separation of catalysts and products, and control of molecule residence time in the reactor. Furthermore, the option of reusing the photocatalyst in subsequent is possible in MPR for further study. Next, the figure shows that the flowchart of the experimental procedure, which started with the synthesis of zinc oxide CN nanoparticles with different loading 1%, 4%, and 8%. The raw materials and the chemical used are Cymbopogon nardus leaf, oxalic acid, and zinc acetate. This slide also shows the material and apparatus used in running this experiment. Next, the figure shows the flowchart synthesis of zinc oxide CN nanoparticles. Zinc acetate dehydrate solution 0.1 m will be prepared. Cymbopogon nardus leaf extract will then be added to the mixture. The precipitate obtained will be filtered and consequently dried in oven under 100 degrees Celsius for 1 hour to remove excess water. Next, the precipitate will be calcined in the furnace under 550 degrees Celsius for 3 hours to remove impurities. After the calcination process, the white powder of the zinc oxide CN will be formed. The white powder zinc oxide CN nanoparticles will be kept in sealed container to avoid contamination prior to use for photocatalytic reactor. The table also shows the method and instrument used to measure all of the 6 parameters and the characteristic of membrane filtration. Okay, ladies and gentlemen, next we move to expected result. There are some expected results in the study to make this research successfully achieve the objective. Firstly, it is expected that zinc oxide CN nanoparticles will be successfully synthesized via precipitation method. Secondly, nanoparticle NF membrane is expected to obtain the best performance in MPR due to the lowest molecular weight cut of MWCO. Thirdly, zinc oxide CN is expected to obtain the best quality of permeate that compliance to the national water quality standards for Malaysia. Fourthly, the membrane flux decline is anticipated to be improved, and the analysis of membrane falling characteristic could be successfully elucidated by using atomic force microscopy (AFM). As a summarization, membrane photocatalytic reactor will become one of the promising methods for polluted river water polishing the process. The utilization of green synthesis zinc oxide Cymbopogon nanoparticles that will be synthesized via precipitation method is to improve the MPR performance for polluted river water treatment will be rather limited today. Therefore, the study proposed to treat polluted river water via MPR under different membranes, which is NF, UF, and MF. Based on the previous study, it is expected that NF will be the best final normalized flux among the membranes. Besides, it's also anticipated that the reduction of polluted river water in terms of pH, color intensity, BOD, COD, turbidity, and ammoniac nitrogen will be more noticeable for NF membranes due to its ability to remove low molecular weight pollutant. The quality of permeate is also expected to be successfully compliant to national water quality standard for Malaysia. It is believed that the study has the potential to eliminate landfill waste with Cymbopogon and polluted river water, which may benefit to the community and society on commercial scale. That's all from me. Thank you.